In this video, we will learn about electrical safety of medical equipment. This series we will cover up in 3 parts. This video, we will learn about what is electrical safety standards and terminology. Let's know about electrical safety standards first. To help verify the functionality and safety of medical devices, electrical safety standards have been established in the United States, European countries, and other parts of the world. The standards differ in criteria, measurements, and protocol. The International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC, organizations based in Europe, provide standards worldwide in partnership with a World Trade Organization. These include standards for electromedical equipment. There are general and specific standards for medical device electrical safety, IEC 60601, AAMI, NFPA 99. The primary standard for medical devices is IEC 60601. General requirements for protection against electric shock hazards are covered in IEC 6060. First, in this standard, each instrument has a class. Class 1, live part covered by basic insulation and protective earth. Class 2, live part covered by double or reinforced insulation. Class IP, internal power supply. Second, each patient applied part or patient lead has a type. Type B, patient applied part earthed. Type BF, patient applied part floating surface conductor. Type CF, patient applied part floating for use in direct contact with the heart. And leakage measurement limits have been developed for equipment types and measurements. They include NC, normal conditions, SFC, single fault conditions. The terminology used in IEC 60601 are protective earth resistance, earth leakage current, touch current, formerly enclosure leakage current, patient leakage current, patient auxiliary current, mains on applied part MAP. Let's understand about some electrical safety terminology. Let's begin with normal condition and single fault conditions. A basic principle behind the philosophy of electrical safety is that in the event of a single abnormal external condition arising, or the failure of a single means of protection against a hazard, no safety hazard should arise. Such conditions are called single fault conditions. Protective earth continuity. The resistance of the protective earth conductor is measured between the earth pin on the mains plug and a protectively earth point on the equipment enclosure. The reading should not normally exceed 0.2 ohms at any such point. The test is obviously only applicable to Class 1 equipment. Insulation tests. IEC 60601-1 lays down specifications for electrical separation of parts of medical electrical equipment compliance, to which is essentially verified by inspection and measurement of leakage currents. Further tests on insulations are detailed under dielectric strength. These tests use AC sources to test equipment that has been preconditioned to specified levels of humidity. The tests described in the standard are type tests and are not suitable for use as routine tests. Earth leakage current. For Class 1 equipment, earth leakage current is measured as shown in Figure 12. The current should be measured with the mains polarity normal, and recommended that the earth leakage current be measured in normal condition only. Many safety testers offer the opportunity to perform the test under single fault condition, neutral conductor open circuit. This arrangement normally gives a higher leakage current reading. Enclosure leakage current is measured between an exposed part of the equipment, which is not intended to be protectively earthed, and true earth. The test is applicable to both Class 1 and Class 2 equipment, and should be performed with mains polarity both normal and reversed. Patient leakage current. For Class 1 and Class 2 Type B and BF equipment, the patient leakage current is measured from all applied parts having the same function connected together, and true earth for Type CF equipment. The current is measured from each applied part in turn, and the leakage current leakage must not be exceeded at any one applied part. Patient auxiliary current. Patient auxiliary current is measured between any single patient connection and all other patient connections of the same module or function connected together. Where all possible combinations are tested together with all possible single fault conditions, this yields an exceedingly large amount of data of questionable value. Patient leakage. By applying mains voltage to the applied parts, the leakage current that would flow from an external source into the patient circuits can be measured. Although the safety tester normally places a current limiting resistor in series with a measuring device for the performance of this test, a shock hazard still exists. Therefore, great care should be taken if the test is carried out in order to avoid the hazard presented by applying mains voltage to the applied parts. This was the terminology definition in electrical safety. In next video, we will learn about class and their definition.